Hi, this is Mike Dorn, and I want to talk a little bit about electrics and a very interesting thing that just occurred in the Arctic Ocean. For the third year in a row, the Arctic has shown two standard deviations of melting from a 20-year mean. I'm going to show you here a graph here, and if you look towards the bottom of the graph there, it shows how the Arctic now for the third year in a row is two standard deviations from the mean. This is only explainable by an electrics. Here's another graph of it. The standard deviations are shown on the bottom there in red, and again it shows that for presently there's two standard deviations from the mean from a 20-year average. Now, electrics is the only way that this is explained because there's a time of year when there's more lightning than any other time of year, and that is basically between mid-August and mid-October, which is where we are right now. And the lightning around the Earth is dependent upon how much land there is when the season is about. So in the southern hemisphere, when the Earth is tilted towards the sun, there's a lot of ocean, and the ocean prevents shorts from occurring and makes it harder for thunderstorms to produce lightning. In the northern hemisphere, there's more land, and the land allows thunderstorms to cause shorts to ground in a more probabilistic manner, and that's why the northern hemisphere has more lightning, and why there's sort of a peak lightning that occurs during the period that I just talked about. These lightning then are behind a global electric circuit that tends to support tropical storms through capacitive couplings. Tropical storms organize, don't get sheared as much. That's the term that meteorologists use during peak lightning. Because of the added CO2 in the atmosphere, CO2 has an electrical conductivity meaning, and this conductivity meaning becomes very clear only when there's more current, and when there's more current, it occurs during peak lightning. If you make a simple model of the global electric circuit, its power equals current squared times resistance, where CO2 moves the variable resistance. Well, if there's no lightning, there's no current, and then there's no power to change clouds. Heat then will move from tropical storms from the tropics to the poles and cause relative melting and cause anomalies. What's interesting about this year is the QBO tends to favor tropical storms when it's very negative, and it just moved into that phase here recently, along with changes in the solar output from the coming out of the sunspot minimum. And between those two factors, the anomalies occurred a little bit later this year, but they occurred nonetheless, and it's more than two standard deviations for the third year in a row. The only way that this is explained is through electrics.